All right, so this is going to be our last video for 4.4 using special distributions. For this example, we're going to do portfolio returns. So we're going to say, let's say you manage a $10 million portfolio. So the portfolio value, let's say VP for value of the portfolio, let's say it's $10 million today, and you want to know the probability of losing $250,000 by the end of the month. So let's say if the portfolio log returns are normally distributed, so let's say RP is let's say RP is our portfolio returns. Let's say our portfolio returns are normally distributed, so they follow a normal distribution with let's say the mean. The average monthly return is, let's say, 1.05%. Let's say the average monthly standard deviation is 2.73%. 2.73%. So let's look at our understanding and choosing the right probability distribution. So this is continuous. So the portfolio returns is continuous. That'd be a continuous random variable. It's not countable. So now we're in continuous, and it's normally distributed. So let's go to our normal distribution. It is, here we go. So normally distributed. So in order to be a normal distribution, the values or the certain conditions have to apply. So some value of the uncertain variable is the most likely. So the mean of the distribution, we know the mean. The uncertain variable could as likely be above the mean as it could be below. So it's symmetrical about the mean, means the bell-shaped curve. And the uncertain variable is more likely to be in the vicinity of the mean. All right, so this is another important assumption, which isn't listed, is that for a normal distribution, it could be any real number. So it could be go from anywhere between negative infinity to positive infinity. The probability of it being very small or a very big negative number, like negative 50%, it's not very high. The probability of it being positive 100% isn't very high, but it's still a possible outcome. So a normal distribution would look like this. So let's let me draw a little bit differently. So let's say this is our mean. This is our average portfolio return, and it's symmetrical. And it has a bell-shaped curve to it. So we want to know the probability of losing $250,000 or greater within a month or by the end of the month. So let's calculate what that would be. So these are log returns. So we're going to do a log, natural log of what was it? So let's do the natural log of 9.5 million. So let's say if you want to know the probability of losing $500,000 at the end of the month, so 500,000 minus 10 million would be 9,500,000 divided by 10 million. This is going to be equal to negative 2.53%. So if the monthly mean log return is normally distributed, then we can calculate this. So we want to know the probability that our portfolio return is going to be that we're going to lose $500,000 or less. So we want to know the probability of RP being equal or less than negative 0.0253. And we can do this in using stats models. So let's I'm sorry, not stats models, in SciPy. So let's go back to our notebook. Again, on the SciPy statistical function page, you can scroll down and you can see it's a continuous distribution. You can do norm. So so we have the normal distribution. This is standard normal. And in it, you have your moments. Let's do. So here's just example code. Then you have PDF, CDF. The location is going to be the mean, and the scale will be the standard deviation. So for this specific example for portfolio returns, if we want to know the probability of having 2.53% or negative 2.53% or less, we'll use a cumulative distribution function. Let's do our portfolio. Let's do portfolio mean, our portfolio mean return, let's say 0.0105. Say our portfolio standard deviation is going to be 0.0273. And now from this, we can calculate the probability. So we can say, let's say my probability, my prob is equal to stats.norm.cdf. So normal distribution, you give it the x value. The x, we want to know the probability of having 2.53% or less. So 2.53 or less, the location is going to be the portfolio mean. And the scale is going to be the portfolio standard deviation. So this is going to give us our probability. And let's say the probability of portfolio returns of negative 2.53% or less would be some percent. We'll do a format. And let's do 100 times my prob and round to the 4 decimal place. Let's print it. So there we go. The probability of this would be 9.49%. So the probability of having 2.53% or less would be 9.49%. Let's ask another question. Let's say we want to know the probability of having returns of 0 or greater. You just want to know what's the probability of having at least positive returns, the probability of having at least positive return. So to do this, if we want to know the probability of our portfolio return being at least positive, so greater than 0, if we're going to use a CDF, for this you can just use the CDF, but for this one, the CDF goes from left to right. So for this, it would be the probability of everything to the left of this. That would be what you would get out of the CDF. But for this one, we don't know everything to the right of it. So we would do 1 minus the probability of our portfolio return being equal to or less than 0. So now with this, we can do the CDF without having to do anything extra to it. So 1 minus this. So let's go back to our notebook. And then the probability of having at least positive returns. So let's do my probability is equal to 1 minus stats.norm.cdf. We want to know the probability of having 0 or greater. So our mean location is going to be the portfolio mean, portfolio monthly mean return. Scale is going to be the portfolio monthly standard deviation of the returns. And let's print it. Let's say the probability of portfolio returns being 0% or greater would be some percent. Let's do format 100 times our probability rounded to the 4 decimal places. So now the probability of returns being 0% or greater will be 64.97%. And you can do this again one more time. Let's say you want to know what's the probability of having returns greater than the risk-free rate. And maybe the risk-free rate is 2%. Probably be a little bit lower than that now, but let's say it's 2%. You want to know the probability of having returns 2% or greater. So that would be 1 minus everything up to 2%. Let's do location. again be the port mean. Scale would be portfolio standard deviation. Remember, all of this is for the log returns. Let's look at my probability. So if the risk-free rate was 2%, this would be the probability of having 2% or greater. So this is this sums up using special distributions. In the next part, we will cover simulation. But this finishes module 4.4 using special distributions.